We're delighted to be at the Institute of Directors for the debate this evening on climate change. My name is David Middleton, as Graham said. I'm chairman of the IEA trustees, and I'm standing in this evening for John Blundell, our Director General, who isn't feeling too well. Can I first ask everyone in the audience to make sure their mobile phone, if they've got one, is switched off? The IEA's educational mission is to improve understanding of the fundamental institutions of a free society by analysing and expounding the role of markets in solving economic and social problems. And we are, of course, an educational charity. Both the Institute of Directors and the Institute of Economic Affairs are strong supporters of free markets. But on the question of climate change, it's possible for supporters of free markets to hold different views. And of course, there are both scientific and economic aspects of the question. The IEA is delighted to be staging this event this evening, which brings together some of the leading experts in both the science and the economics of climate change on opposite sides of the debate. We're especially grateful to the IEA donor who has made this event possible. I'd also like to express particular thanks to two of the speakers, Professor Fred Singer for flying over from the United States, and Dr. Sam Frankhauser of the LSE for standing in at very short notice for one of our advertised speakers, Michael Grubb. The title of this evening's debate is Do Science and Economics Support Government Action on Climate Change? Let me now briefly introduce our four speakers in the order in which they'll speak. Professor Mike Hulme is Professor of Climate Change in the School of Environmental Sciences at the University of East Anglia. He currently leads an EU consortium of researchers contributing to the development of EU climate policy. In addition to co-editing the academic journal Global Environmental Change, he is author of Why We Disagree About Climate Change. Professor Fred Singer is Professor Emeritus of Environmental Science at the University of Virginia and founder and president of the Science and Environmental Policy Project. He was the founding director of the US National Weather Satellite Service. He has written or edited over a dozen books, including Nature, Not Human Activity, Rules the Climate, and Climate Change Reconsidered. Dr. Sam Frankhauser is Principal Research Fellow at the Grantham Research Institute on Climate Change and the Environment at the London School of Economics, where he focuses on carbon markets and the economics of adaptation. He is also a member of the UK's Committee on Climate Change. He has served on several assessments of the Intergovernmental Panel on Climate Change. Lord Lawson, Nigel Lawson, a former journalist, was Secretary of State for Energy between 1981 and 1983, and Chancellor of the Exchequer between 1983 and 1989. He was a member of the Lords Select Committee on Economic Affairs, which in 2005 produced a report on the economics of climate change. His recent book was called An Appeal to Reason, A Cool Look at Global Warming. Well, our plan this evening is that each speaker will talk for about 10 minutes, and we'll then throw the debate open to the floor for brief comments or questions. After about an hour of questions, I'll ask each of the four main speakers to make a 2 or 3 minute summary statement in which they may choose to comment on some of the points or questions from the floor, but they won't be answering particular questions as we go along. They'll be making a note of them and may answer some of them at the end. Let me now call on our first speaker, which is Professor Mike Hulme.
Thank you very much for the introduction. It's a great privilege to be here in this wonderful room in London, talking about climate change, which is something that has preoccupied the entirety of my professional career, having started off my PhD research back in the early 1980s, trying to understand the relationships between climate change and drought and society in Sudan and Ethiopia in Northeast Africa. I believe that we need to start this debate by exploring our idea of government. If we think broadly across a wide range of social, environmental, and economic concerns, the important question is, what roles do we see as legitimate for a national government to adopt? Is our preference for a small and minimalist state, or perhaps for a large and interventionist state? Or expressed differently using the language of Anthony Giddens, sociologist, do we believe in an enabling state, or, as he has recently written, an ensuring state? Now, this evening I suggest that on our panel we have very different views on these questions about the nature and role of national government. And these different positions on the role of government will be linked quite closely to our different political ideologies and prejudices. And to put on record, my own personal instincts and my own political beliefs are for a more interventionist state than a minimalist one. So, for example, I believe in a state that would play a significant role with regard to wealth redistribution, both within and between societies. Now, I make that opening statement very explicitly and deliberately before I want to move on to see what it is that science and economics might have to say about climate change to guide state policies. And I suggest that, first of all, we should be clear that neither science nor economics should determine government action. There is, of course, a counter view to that, the technocracy model of government, which would actually argue that indeed it is science, expertise, technocrats that should actually determine and formulate government policies. I don't buy into that particular model of science policy interaction. But I say that neither science nor economics should determine government action, not because the science and economics of climate change are in some sense wrong or poor or incomplete. Although, of course, we could say that in some sense, both science and economics are all of these things. Science is never complete, economists are usually wrong, and the practice of neither science nor economics lives up to their ideals. No, I make this claim about neither science nor economics driving government action is because I believe it should be determined by politics. Politics, which is, if you like, the conduct of social relations involving authority and power in order to make decisions. Politics is what we have, and that is where government action and policy should be formulated. And then in a liberal democracy, which we possess in this country, that means that government policy should be determined through debate, argumentation, and through lobbying. And for me, that's why in 2007, when the Heathrow climate camp protesters were marching against the third runway at Heathrow, and their slogan was, "Armed only with peer-reviewed science," I believe they were wrong. They were armed with far more than just peer-reviewed science. They were actually armed with their political commitments and their beliefs. I also think that was wrong when earlier this year, the then Danish Prime Minister, Anders Rasmussen, before he moved on to NATO, at the end of the Copenhagen Climate Conference, which had 2,000 researchers present at, he was wrong when he called upon scientists in the final plenary to give him the number. He said, I need your assistance, speaking to the researchers, I need your assistance to push this process in the right direction. And in that respect, I need fixed targets and certain figures, and not too many considerations about uncertainty and risk and things like that. So if science and economics cannot determine climate change policy, what can they contribute? Well, science can and has contributed very clearly to our knowledge that as levels of greenhouse gases and other climate-forcing agents in the atmosphere accumulate, then there are changes in the nature and frequency and type of climatic and other consequent environmental risks that ecosystems and peoples and communities are exposed to around the world, both now and we believe in the future. But science is not able to tell us, crucially, how large or small these changing risks will be, or where or when exactly they may strike. For example, one of the key parameters that climate scientists seek to understand, so-called climate sensitivity, the range of possible values of the climate sensitivity remains extremely large. So these uncertainties that come out of good science leaves plenty of manoeuvring space for politics to properly do its job of weighing evidence against political goals and priorities, judging the public will. And economics, what can economics contribute? It can and has contributed very clearly that these changing climatic and consequential environmental risks bring costs with them. And ameliorating these risks, mitigating them, if you might like, either through mitigation or adaptation, ameliorating these risks is also costly. But, crucially, since ethical judgments, for example, around the discount rate or about equity weighting, because ethical judgments determine the size of these costs in any economic analysis, economics, too, allows plenty of manoeuvring space for politics to properly do its job, weighing evidence against political goals and priorities and assessing the public will. So, in conclusion, yes, I believe in government action on climate change, not action that is driven and determined by either science or economics, but action that is decided on the basis of political ideology, risk evaluation, ethical judgments, public deliberation, and a democratic sensibility. And as I argue in my recent book, Why We Disagree About Climate Change, we disagree about climate change not because in some way the science is faulty or the economics is incomplete. We disagree about climate change because we carry different worldviews with us, we hold different values and beliefs, and we argue for different roles for government to play in our liberal democracy. And these differences, these disagreements about climate change will be seen this evening in abundance from the panel and also from the floor. Thank you.
Our next speaker is Professor Fred Singer.
Thank you very much. I'm delighted to be here. I've spent several years living in England, and it's always good to be back. I want to address a single issue, one issue that I consider to be most important. And I think this is a basic issue that underlies everything else. And that is a question of what is the cause of climate change in the last 100 years. Is it primarily natural, or is it primarily human-caused? We know from geologic experience that the climate varies naturally. It both warms and cools on different time scales. 300 years ago, the Thames was freezing over every winter, and you could have ice fairs on the Thames. That was the so-called Little Ice Age. 1,000 years ago, it was warm in England, and according to Hubert Lamb of the University of East Anglia, the Dean of Climate Studies, I would say he's probably was the leading expert on historic climate. In those days, when it was much warmer than today, wine was being grown in Yorkshire, and the French were complaining bitterly about the import and competition from British wines. And those days may not return, but those are historic facts that are recorded. So we know that climate changes on many, many time scales. In the last century, the climate has both warmed and cooled. Some of you here may be old enough to remember that between 1940 and 1975, the climate cooled, and there was great anxiety about the approach of a coming ice age. Now, we're sure there will be another ice age, but we don't know when. Another ice age would cover the north of England, or all of Scotland, of course, but the north of England, with thick sheets of ice. Sea level would drop. You might be able to again walk from England to France, because there would be no North Sea. These are the conditions that existed 20,000 years ago. We know all that from geology. So let me return to the main question. We know that natural changes occur all the time, and there's no reason to think that natural changes have suddenly stopped in the 20th century. But we also know that human activities, the burning of fossil fuels like coal, oil, and gas, has enriched the atmosphere with more carbon dioxide. Notice the use of my word enriched. There's a purpose in this. Carbon dioxide is plant food. That's what plants live on. The more carbon dioxide, the faster they will grow, and the better they will grow. Again, we have adequate experience from hundreds of agricultural experiments. And I always say to my friends, maybe we should thank the Chinese for putting more carbon dioxide in the atmosphere instead of worrying about it. Again, back to my question. Carbon dioxide is a greenhouse gas. According to well-established theory, it should produce warming of the atmosphere by the greenhouse effect, by an enhanced greenhouse effect. The question is how much? Is it important or is it insignificant? That is the issue. How can one tell? How would you tell? Here you have thermometers, let's say, rising, temperatures are rising, and you ask the thermometers, what's the cause? And they're dumb. They can't tell you. They won't tell you. All they tell you is the temperature. Well, you have to look at evidence. And there is plenty of evidence which will tell you whether the warming is caused by increased carbon dioxide or whether these are natural causes, be they internal, like ocean circulation changes, or external, like solar activity changes. Now, there are in existence now two schools of thought. The United Nations has set up the IPCC, the Intergovernmental Panel on Climate Change, which has now produced 4 reports, each more scary than the previous one. And in the last one, they say they're between 90 and 99% sure that the warming of the 20th century, the overall warming, is human-caused by greenhouse gases. And then we have the organization that I am part of, called the NIPCC, which some people say stands for not IPCC or never IPCC. Actually, it stands for Non-Governmental International Panel on Climate Change. It is not set up by governments. It is not beholden to any government or to anyone else. It is international. Our scientists come from 16 countries. True, that's a smaller number than the IPCC. We don't have scientists from Albania and Zimbabwe, but we have them from, shall we say, countries where climate science is practiced on a large scale, including Britain. So, the NIPCC says the opposite. We say that the human contribution, while it must be there, is not detectable. It's too small. And there's a scientific reason why that is so, which one can go into, but this is not primarily a scientific discussion, but I'd like to give you a hint. The hint has to do with negative feedback, with clouds. And clouds can act in such a way as to diminish the effects of carbon dioxide, and apparently that's what may be taking place. And it's an active field of research, and we don't have final answers. But we do know that the human contribution is not noticeable. So what we have done is to look at evidence, as any lawyer would, or as any person would who's interested in solving a problem. The IPCC has produced several pieces of evidence. In the popular press, for example, you read a great deal about a consensus of science. That's something that Al Gore likes to talk about, our former vice president. Well, you know, of course, that consensus doesn't prove anything, particularly in science. In fact, one should be suspicious of any science where there's a consensus. Someone said, consensus is not science, and science is not consensus. In fact, in the United States, 31,000 scientists and engineers have signed a petition against the Kyoto Protocol and against the global warming scare. And just recently, more than 200 of physicists, and I'm one of them, have signed a petition to our physical society to withdraw and change an atrocious climate statement that they have published, which simply echoes the IPCC. And the American Physical Society has agreed to examine this statement and perhaps change it. And that we published a letter in Nature to that effect. This is the first time a scientific society has actually not withdrawn a statement, but agreed to re-examine a statement. And I predict that when the American Physical Society looks at the statement from a fresh point of view, they will arrive at a conclusion similar to ours. A more serious issue that, or a piece of evidence, so-called evidence, that's brought forward, is that of melting glaciers. You've all heard about melting glaciers, shrinking sea ice. It's in the papers almost every day. If you just think about it from a logical point of view, this is not science, this is logic. You will see that all this tells you is it's getting warmer. It doesn't tell you the cause. A glacier, shrinking glacier, cannot tell you whether the cause is human or anthropogenic or whether it is natural. So it's useless. It doesn't add information. That's not evidence. Another so-called piece of evidence has to do with correlation between increasing CO2 and increasing temperature. Again, if you look at it in detail, you find that sometimes the correlation is positive and sometimes it is negative. Between 1940 and 1975, during the cooling period that I spoke about, carbon dioxide was increasing steadily and rapidly after World War II, yet the climate cooled. And more recently, in the last 10 years, the climate has not warmed. There's agreement on that. All the data show that. The climate has not warmed in the last 10 years, in spite of the fact that CO2 is increasing more rapidly. thanks to the Chinese. Well, correlation, therefore, doesn't in any case tell you the cause. And in this case, the correlation doesn't even help. Well, the final piece of evidence that the IPCC has turned to is to say, well, all of our climate models show a warming, therefore, it must be true. I don't know how many of you have worked with models, but I know a number of you are economists, and you probably have some experience with economic models. Let me tell you, the climate models are worse. They are really very, very difficult, and the results of models depend on the assumptions that you put into them. One way to judge that is the fact that of the 22 climate models in the world, major climate models, they all disagree with each other. Why? Because of the assumptions that are put into them, the parameters that are chosen, which are arbitrary, although they all claim to be chosen by expert opinion. But, you know, expert opinions vary. In any case, the models never predicted a decrease in temperature. They all predict increases in temperature. They all predict a warming. None of the models has predicted the cooling of the last 10 years. Not one. In retrospect, always in retrospect, one can always try to find some reason why the climate might cool. But it is clear that what is happening is that the natural forces are overwhelming the greenhouse effect. Now, there are specific fingerprints that we have looked at to see whether one can tell whether the climate is climate change is human-caused or natural. I'll give you a couple. Every climate model predicts that the polar regions should warm more rapidly than the equatorial region. In reality, we find that the Antarctic has been cooling for the last 50 years. It doesn't follow the models. A particular fingerprint that we have worked on and that is expounded on in our report of the NIPCC has to do with the fact that a greenhouse effect produces a characteristic fingerprint that you can see in the model results. The fingerprint consists of a hot spot over the equatorial region at an altitude of about, maximum of about 6 miles. The data, which have been produced by Hadley Center, show the opposite result. Not a hot spot, but a cool spot. Disagreement is very strong, and of course there's great debate now whether this is so, and there are people who are trying to invent new data. In fact, it's quite interesting. The main objection against our work has been, well, there must be something wrong with the data. Here's where we stand. Of course, we think we will prevail in this because every fingerprint we examine supports natural as against human causes. Now, I'll quickly mention consequences. Very quickly. If it is human, there's no need to do anything yet until you determine whether or not a warm climate is good or bad. Again, a logical point. We're all agreed that a colder climate is bad. If a warmer climate is also bad, it means that the present climate has to be optimum. That's very unlikely, isn't it? Anyway, it is clear also that very little will be done to affect the climate. In fact, very little can be done by human activities, by controlling emissions to affect the climate, and we'll see the results of that in Copenhagen in a couple of weeks. One final point, just to sum up. I'm not worried about climate change. Not at all. We know how to adapt to climate change better than our ancestors. We don't have to live in caves anymore. We have the means to adapt to both cold and warm climates and live nicely. What worries me, the only thing I'm scared of, are politicians who, in their zeal to control the climate, to, quote, save the climate, will introduce policies that will ruin the economy. That is my main concern, and I hope you share this concern with me. Thank you.
Our next speaker is Dr. Sam Frankhauser.
What I'd like to do is answer two questions in the 10 minutes I have, and each one of those questions come with a series of sub-questions, if you will. You will have heard that one of the headline numbers that is floating around is that we have to reduce global greenhouse gases by 50% by the middle of the century. That's global average. Developed countries would have to do 80%. So the first question I want to ask is, why is a 50% cut sensible? The second question I want to ask is it doable, and can we do it within sort of our economic paradigm of market-based prosperity? So the first question is, why is something like a 50% cut sensible? Let me disaggregate that into three sub-questions. The first question is, why is reducing emissions at all a sensible thing to do? And why don't we just adapt our way out of trouble, as we just heard as a proposition? And then thirdly, why is the good number 50% and not any other number that you can think of? So why should we reduce emissions at all? There are various reasons that have been put forward. The IPCC has put forward 5 reasons for concern, and don't worry, I'm not going to list them all. The Stern Review has sort of given a cost-benefit answer to the question, so saying the cost of doing something about the problems are less than the benefits of doing something about the problem. In the Committee on Climate Change, we've taken a risk-based, a precautionary approach, and that's the approach that I'm really most comfortable with. That says that it's simply unwise, it's simply careless not to take some precautionary measures. You can disagree with the science, and I'm sure there are quite a few bits or some bits in the scientific body of literature that are wrong, but the fact is that the scientists are 90% sure that we have a problem. Now, I don't know about you, but if somebody tells you that you have a 90% chance that your house might burn down, or your house might be burgled, or there's a terrorist attack, you sort of take measures, you take precautions about that. It's just some sensible thing we do. That's why we have all manner of insurance, and climate change, in a sense, falls into the same category. So second sub-question, why don't we just adapt our way out of trouble? I spend a lot of my time telling people just how powerful adaptation to climate change is, and it is very, very powerful. People are incredibly good at adapting to different climates and to changes in climate and so on. So adaptation very clearly is part of the answer. The worry is that we are sort of confident we can adapt to something like 2 degrees, maybe even 2.5, maybe even 3 degrees. We know we can adapt to that. But we're not at all sure that we can adapt to something like 4 degrees or 5 degrees, which is what we're going to get unless we reduce emissions. Now, maybe we are, but we're not sure. And again, it sort of seems cautious to not sort of try our luck. So, next question is, why is 50% a good number? Why not any other number? 50% is probably, not probably, it is a sort of a slightly arbitrary number, but where it comes from is that it gives us a 50-50 chance of limiting climate change to 2 degrees warming. And 2 degrees, at least in my books, and I think in most other people's books, is something we can probably get used to. It's not going to be cost-free. There are going to be casualties. One casualty that we are going to have are coral reefs. Scientists tell us that coral reefs only survive something like 1.5 degrees warming. Now, you may not be bothered about coral reefs, but they're more than just pretty fish. There's there are millions of people whose livelihood depends on it. There are 20% of known fish species that are sort of based in coral reefs. Economists like to value all these things, so they have put the price tag on the services that come from coral reefs. The price tag is something like $700 billion a year. You don't have to believe that number either. I don't do, but what I do know is it's a big number. So 2 degrees is, is not an extreme sort of target. It's something that we can survive. But more importantly, I think, is that the 50% emissions cut reduces the probability of something a lot worse than 2 degrees. It reduces the probability of ending up with something like 4 degrees to a couple of percentage points. And that, again, is the sort of precautionary story why I think we should do these things. Second question I wanted to ask is, can we do the 50%? Is it doable? Is it consistent with our view that we want a prosperous world, we want a market-based economy? Let me disaggregate that question again. Is it doable? I very much believe it is, and in the Committee of Climate Change, we have set out a blueprint of how the UK can reduce its own emissions by 80% by the middle of the century. It's not straightforward. It's a very, very tough task, but most of the technologies that we need, we're sort of aware of, we know of. Some of them we have to test, but most of them we sort of have a fair idea that they're going to work. Is it going to bankrupt the economy? There are economic models about, and economic models tell us that the cost of doing all that is less than 1% of GDP by 2020, and maybe between 1 and 3% of GDP by 2050. Now, I don't sort of fully trust those models either, but they have the benefit of being economic models and not science models, and therefore there must be something to them. But you can double those numbers if you don't believe them, and the story still holds. Over a 40-year time horizon, that's sort of within the noise, that's within the range of uncertainty that you have about future well-being over a 40-year time horizon. It's a hell of a lot of money in absolute terms, but if you look at it over 40 years, it becomes part of the modeling noise, if you will. Is it consistent with our ideas of a market economy? Yes, it is consistent in a sense that the policies that we recommend, that we adopt, are very much market-based instruments. The whole idea that we want to curtail greenhouse gases goes back to Pigou, which was a fairly decent economist in the 1930s, about wanting to internalize external effects through price mechanisms and things like that. And in a sense, that's what we are doing. The biggest climate change instrument that we have to date is a cap-and-trade scheme that is European-wide, and cap-and-trade is a market-based instrument. It gives entrepreneurs the incentive and the flexibility to innovate and to react to price signals. That's not, that's very consistent with the sort of philosophy of markets and entrepreneurship that I have, and I'm sure many of you have. So we can solve the problem in a market-based way. The final thing I sort of want to say is I'm sort of being a bit defensive talking about costs, but somebody's costs is another person's revenue, and so I want to finish by pointing out that climate change actually also has opportunities attached to it. Do you know of any economic sectors? Can you name an economic sector that grew by 75% last year in the middle of the biggest economic crisis? I name you one: climate change. And that number doesn't come from any academic analyst. That number comes from the equity team of HSBC. So hard-nosed bankers, they came to the conclusion that this is what has happened. What they did is they looked at their 65,000 listed companies in their database. They tried to determine how many of those 65,000 have activities that you can roughly call climate change: energy efficiency, waste management, clean cars, battery technologies, renewable energy. And they sort of found about 1,000, I think, technologies, and they looked at the stock, the market valuation of those 1,000 companies, and they concluded that the value of the climate change sectors in the year 2008 has gone up by 75%. As a result, climate change as a sector is now bigger than defense and aeronautics. Again, that's HSBC saying that. I just believe them. I'm just reporting those numbers. But in a sense, that's sort of where I draw a bit of comfort from, and let me sort of finish with a naive, perhaps wishful thinking type statement. I think the way we are going to solve this problem is by having industry realizing that climate change can also be an opportunity and creating interests in the sort of change that society and some of us want. That's the way we solve problems like ozone layer depletion. That's the way we solve problems like acid rain and particulate matters. It's when industry starts realizing there's an opportunity involved and you can actually become rich and be prosperous by doing these things and still live in a market economy. And I think we're reaching the point where, at least in Europe, people are starting to realize that. Thank you.
Our final speaker is Lord Lawson.
Thank you very much and good evening, everybody. I hope you'll forgive me that I had a very, very busy day today because this was the day on which I launched, along with Benny Peiser, our director, who is sitting there, a new think tank, the Global Warming Policy Foundation, which is designed to try and bring integrity and balance into an important debate which has greatly lacked integrity. We've seen examples of that just recently, and alas, greatly lacks balance. I do apologize. And I hope that we will be able to make a big difference to the debate that is going to be ongoing. The debate that we've been having so far has had something of a surreal nature. The contributions have been interesting, but it has been distinctly surreal. And indeed, maybe we should have been warned about that, because if you look at the papers that we were given, there's no motion at all on the paper. So the whole thing is slightly surreal. I would like to make a few observations, however, on some of the things that have been said, particularly by the last speaker, Mr. Fankhauser. But before I do, I'll mention a little bit about the others. Mike Hulme is a conspicuously attractive and elusive character in this debate. Wherever you think he is, he's somewhere else. And he's changed a great deal, which I commend him for, because he was a kind of mainstream conventional wisdom decarbonisation man when he was running the Tyndall Centre, and you only have to read the papers which were produced by the Tyndall Centre at the time, and how they were berating the government for not doing enough in the way of decarbonising and forcing the country to decarbonise. If you look at his book, however, which he referred to, and it's a fascinating book, he's really, I think, insofar there are two sides in the debate, on our side. He said this, for example, in seeking to govern climate, humanity is attempting something that has never been attempted, global governance of the global atmosphere. And he clearly thinks that is completely unrealistic, and he's right. And he concludes, there are other ways of thinking about climate change which do not require unreachable global agreements. A good point, because they are, of course, unreachable. And he concludes, rather than being approached, and this is where I think it's slightly elusive, but one day I shall understand him, rather than being approached as a problem to be solved, climate change can become an imaginative resource to be used. I can imagine a minister asking Mike Hulme, who, as I say, is an extremely attractive character, for advice. And what should I do about climate change? He said, well, Minister, it's an imaginative resource to be used. Frankhauser gave, I am not competent to pronounce on the science as he is, but he gave some very telling examples of where logic has gone out of the window and it needs to be brought back in. I don't know, it is a question. It is a question, obviously, as to how much the greenhouse effect the growth of carbon dioxide emissions has had on the global temperature. And I think we really don't know. What is quite clear is these computer models have proved very poor predictors indeed. So I don't blame the scientists, it's a very complicated matter. Clearly the jury is out on this, and I don't express a view. Now, Dr. Fankhauser, or Professor Fankhauser, it might be, I'm not sure, and he came in very much at the last minute, I don't know. He made some extraordinary assertions. One of them, I think, is demonstrably, many of them I've had grave doubts about, but there are just mentioned two. First of all, he says you must believe the conventional view of the science and therefore the conventional policy prescription, because 90% of the scientists are on this side. First of all, even if 90% of the scientists were on that side, it doesn't mean that they're right. And incidentally, a great illusion, which I think the BBC particularly is guilty of falling into, is that if you believe the majority view, and it is a majority view among climate scientists, then you must accept the policy recommendation of decarbonisation, massive decarbonisation. And it's not incidentally just 50% by 2050. That's slightly disingenuous, because the programme is that it goes on after 2050 and goes on to virtually complete decarbonisation. But in fact, not only do you not have to accept that, but it isn't, the 90% is totally untrue. The most reliable survey of climate scientists is one conducted by Professor Hans von Storck of the Meteorological Institute of the University of Hamburg in 2007, along with Dennis Bray, a sociologist who was used to constructing these surveys. And they asked the climate scientists a number of different questions. And it's interesting that Hans von Storck himself is one of the scientists who accepts the majority view of the science, and which is that most of the warming of the last quarter of the 20th century was due to man-made carbon dioxide emissions. And in fact, how they broke these hundreds and hundreds of accredited climate scientists around the world was about 2/3 said yes, and about 1/3 said no. And indeed, the ones who said no were slightly more strongly of that opinion than the ones who said yes. So it is a much more even balance. So we don't know. One thing which was, however, very striking was when these hundreds and hundreds of climate scientists were asked what they thought was the most serious problem facing the planet this century. How many do you think said either global warming or climate change? 8%. 8%. The government in this country is worried because the number of people in the surveys who say that climate change is a major problem has fallen to around about 40%. And that's why they've got this really mendacious film, which many of you know about, to try and frighten the public, which I think is a disreputable way in which, for any government, it is not party politics, any government to behave, to get them to think climate change is more serious, and evidently they do, by showing carbon dioxide emerging from the chimneys and the houses and the factories and so on as huge black smoke leading to a massive black cloud which envelops the whole Earth. That's not what it is. This is totally mendacious, and should, if it were a commercial organisation, that advertisement wouldn't be able to be screened. But anyhow, as I say, they're worried, the government's worried that only a minority, only 40% of the people, think this is a really existential threat. As I say, of the climate scientists, only 8% think it's the most serious threat facing the planet. So what do we do? Then I don't want to take too long. There are two approaches which have been suggested. One of them is the sensible one, which mankind has adopted throughout the ages and adopts around the world where climates are very different in different parts of the world. and that is you adapt. And the technology for adaptation has never been better. You only have to think of, in farming, genetic modification, bioengineering, it's there, and a whole host of ways where technology is far more advanced than ever been before. And there are many reasons why it's sensible to adapt. First of all, it doesn't matter, this is Fred's point, what the cause is of any change in the climate, whether it is carbon emissions or whether it's natural forces. The same adaptation is required, and you do the same thing. Another thing is that there are huge benefits from a warming planet. Just to look at the IPCC's own report, not what their summaries for policymakers, but the thing itself. Under health, for example, they say that they have a big table which shows the various possible health consequences ranged in order of probability from downwards, from virtually certain to probable to possible, likely. The only one which is in the virtually certain category, this is in the IPCC's own report, is fewer deaths from cold-related diseases. That's the only one they're really confident of. Or you take agriculture, food and agriculture. Dr. Fankhauser says, my goodness me, if we go above 2 degrees, really in big, deep trouble. And 2 degrees, incidentally, is 1¼ degrees, because we're already 3/4 degrees Celsius above pre-industrial levels now. So he says there's a little bit more. Disaster, my goodness me. Well, even the IPCC, which is very good at assuming all the worst possibilities, and assuming, incidentally, an incapacity to adapt in most of the world, and an incapacity of technology to improve, which is somewhat unrealistic over the next 100 years. Even then, they say anything up to 3 degrees rise would be actually beneficial for food production globally. So what I'm saying is there are benefits. Of course there are disadvantages too. If it does get warmer, and it might not. Might not. We don't know. Nobody knows. Well, maybe Dr. Fankhauser knows, but I have to admit that I actually don't know what the temperature is going to be like in 100 years' time. I'm terribly sorry. Within these 4 walls, I have to confess to this ignorance. I don't. But we'll see. And but what is important is that you will be able to pocket all the benefits, and there are many benefits. So the IPCC accepts that, and you will be able to, however, by adaptation, reduce you won't eliminate them altogether, but reduce greatly the extent of the disadvantages. So this is clearly far more cost effective. Dr. Fankhauser says we have to have an insurance policy. Well, let's say what this insurance policy is. If you do decarbonize, as is said we should do, even if you could get the global agreement, which you can't for very good reasons, but if you could, that would slow down the growth in the world as a whole, including the developing world. Now, just wait a minute. He said, well, it's only a little bit you slow down the growth. It may seem big numbers, but it's only a small percentage. If you slow down the rate at which these countries can develop, what you are doing is condemning tens and tens of millions of people in the developing world to unnecessary poverty, unnecessary malnutrition, unnecessary premature death, and unnecessary diseases. I think that's positively immoral. I think, so far from being an insurance policy, I think it's an insurance policy insofar it is one which comes at a totally unacceptable cost. So I'm afraid I'm stopped there, but I cannot agree, I think, with a single thing that Mr. Fankhauser said. However, the other two said a lot of sensible things. I understood Professor Singer. I didn't understand fully Professor Hulme, but I thought it was extremely sensible what he said. Thank you.